In this video, we're going to focus on understanding what a chemical change is as opposed to a physical change. Now, a chemical change occurs when a reaction between multiple substances, be they elements or compounds, occurs that results in a new substance being created that wasn't there before. Now, all chemical changes can be grouped into three general categories, the first of which being what we call an inorganic chemical change. Inorganic chemical changes are chemical reactions that occur where the elements or compounds do not involve one specific element, that being carbon. So if there's no carbon involved in the chemical reaction, this is an example of an inorganic chemical change. Now, the opposite of an inorganic chemical change is an organic chemical change, which involves a reaction between compounds that do involve the element carbon. Now, we call these organic, meaning alive, technically, because carbon is the element that is the foundational basis for all living things. Therefore, any reaction involving organic compounds, that being compounds containing carbon, are defined as organic chemical changes. And one example being burning firewood, since firewood is made of wood and wood originally comes from trees, and since trees are plants, examples of organisms, this is defined as an organic chemical reaction. Now, one subset of organic chemical reactions are what are called biochemical reactions, and again, the tip-off is the prefix bio, meaning life, meaning that these are organic chemical reactions that occur within living organisms. And these can be further broken down into two broad categories, the first of which being growth, that being when organisms use chemical reactions in order to grow bigger, and metabolism, which is when organisms use chemical reactions in order to produce energy. So looking more specifically at a single chemical reaction, if we look at the chemical reaction that is used to produce water, which has the chemical symbol H2O, we can see that if we look at the starting substances that produce water and the actual structure of water itself, we see that these are different. So the starting chemicals in order to make water are two gas compounds, or two gas elements rather. So H2 is hydrogen gas, which is one element, and O2 is oxygen gas, which is the gas in the atmosphere that we all need to breathe. And when these two react with each other, they undergo a chemical reaction to produce H2O. Now, in every chemical reaction, the starting elements or compounds, the chemicals that react together, are called reactants, and the finished compound that did not exist before are what we call products. And when a chemical reaction is written out like this is what we refer to as a chemical equation, because it shows that the starting reactants that we have react together in order to form our products. Now, if we take this reaction and if we flip it around going the other way, we get what we call a reverse reaction, because all that we're doing is that we're taking the original chemical equation or the original chemical reaction and flipping it around. So because chemical reactions by definition produce a new substance that did not exist before, they, in order to take the original chemical reaction and have it go backwards, they require a different chemical reaction in order to be reversed. Hence why we refer to this as a reverse reaction. Now, this is why a lot of science teachers say that a chemical change is different from a physical change, because chemical changes are irreversible. Now, this is not exactly true, so a better way of explaining this is you cannot simply take a chemical reaction and do it backwards. You actually need a separate chemical reaction, that being the reverse reaction, in order to take a chemical change and do it backwards. So if we were to write the reverse reaction of making water, that would be where we take H2O and have it go backward, breaking down into hydrogen gas and oxygen gas, which is a different chemical reaction. Now, this is very different with physical changes. One example of a physical change that we can look at are simple state of matter changes. And we can look at an example of a state of matter change that everyone living in Canada has seen before. So a state of matter change can involve ice, that being solid water, and we know the chemical formula for water is H2O, turning into liquid water. All that we need to do to get ice to melt is to increase the temperature so that water turns from a solid into a liquid. But regardless of whether it's ice or whether it's liquid water, we know that it is still water, H2O. So because the chemical structure of water doesn't change, this by definition is not a chemical change. And this also applies when we take liquid water and when we turn it into gas, also known as water vapor, which we can also do by increasing the temperature. So, because we can see that the chemical structure or the chemical formula of water doesn't change from solid to liquid to gas, we can conclude that state of matter changes are not chemical changes, but are instead physical changes. So the two characteristic reasons why these are not chemical changes is that we can take a physical change and easily reverse it relatively easily compared to doing a chemical reaction backward. So if we converted ice into water vapor by increasing the temperature, all that we need to do to go the other way to turn water vapor back into ice is decrease the temperature, and there is no second chemical reaction that is required. The second reason, again, why this isn't a chemical change is because the chemical structure of the compound that is involved, water, does not change as we go through physical changes. Another example of a physical change but not a chemical change is what happens when we take salt. The chemical formula for salt is NaCl, which we'll look at later, and we can see that each of these has a charge to it. We'll explain why this is the case. But when we put salt into water, we can see that the chemical structure does not actually change. So when we put Na plus and Cl minus, or NaCl, that's salt again, into water, basically what water does is it takes the two halves of salt and separates them from each other, and this is what causes the salt to dissolve. But we see that we still have the two halves of salt, Na plus and Cl minus, which means that we haven't actually created something new. All that we've done was separate the two halves of the compound that makes up salt. And for this reason, solubility changes when we dissolve certain chemicals into other chemicals are also physical changes. So in conclusion, physical changes can alter the shape, they can alter the size, and they can even alter the state of matter of whatever the substance is that is being altered, but don't actually change what the chemical structure is of that substance, whereas by definition, a chemical change does. In the next video, we're going to look at how we can predict that a chemical change is going to occur based on observations that we can make.